Hey and welcome back. Now that we set up the filter dialog successfully, it's time to actually implement the ML Kit libraries to my project. To do that, let's navigate to libs.versions.saml and add the text recognition here that I have already done it. We use the 16.0.1 version, and also I'm gonna add it here inside the libraries. Now let's go to the build.gradle.app, and down here I'm gonna add this text recognition library here, like that. And of course we want one more AAR file, so let's go to the project, and you can get it from my GitHub resource, this core 00.7 AAR file. And using this library, we can actually convert each frame of the WebRTC into a bitmap file, and then using this again, we can convert it back to the WebRTC frame and proceed with the continuous flow. So that means that we extract the bitmap from each frame, do our AI process with ML Kit libraries, and then convert it back to the VideoFrame and send it to the target. You have to place it inside the libs folder below your app folder, and then you of course have to add it inside the build gradles file like this, and then we will press sync. So if your app is built successfully, we are ready to go and use these libraries. So as I explained earlier, how does collaboration magic work? It's actually inside our WebRTC factory class when we are about to capture our video frames and send it to the target. So up here inside the start local video function, we have a function named initialize. So what we want to do is actually, instead of this observer, I'm going to actually create an anonymous object that is going to extend from capture observer and implement the member of it. So I don't want to do anything with when the capture is started, either with when the capture is stopped. I just want to work with this on-frame capture. So we do our process here, and for each frame, what we do is we simply want to, first of all, create a coroutine scope. Of course, since it's a heavy operation, I'm going to use the default dispatcher and launch a block. And when our job is done, I'm going to switch back to the main context or main dispatcher and proceed with the integrated frame to that thing. The dispatcher main, I'm going to open the block like that and then proceed with the new frame. But how we are extracting this video frame is actually like this. I'm going to add two helpers class inside my util package. So let's create a package named helpers and paste these two classes here. The first one is VideoFrame, which is a frame that contains a bitmap of that frame, and another class that converts a bitmap back to a video frame. So let's go back to our WebRTC, and down here inside the coroutine scope, we can get the VideoV, use VideoFrame that we just created recently, pass the frame to it, or P0. Processing flags is going to VideoFrame.processing none. And then for the timestamp, we are going to pass the timestamp of the frame. So P0.timestamp millis. And if it's null, we want to use system current time in millis, just like that. And then we want to extract the bitmap out of it by UV. Let me fix it. If it's null, we want to return from this launch block. It's time to, get the processed image here. Since we are going to, handle 10 filters here. I don't want to write anything here, so I want to create a pipeline, a video effects pipeline, and then pass the bitmap to it, and then it will decide if any of the filters are set to on or any of the filters on online. It will process the video and give it back to this function, and then we will convert it back to the video frame and so on. So let's go inside our utils package, create another package named image processors, and then I'm going to add this video effect pipeline here. So as you can see, it will create an instance of our module. For example, this is a TextRecognitionEffect, and for each frame process, we will get a bitmap and the enabled this blueprint that checks if any required filters should be set up on the process version. So down here we will check if the, for example, text reconnection is set to on. We want to use this filter and apply to it. So let's go back to our WebRTC factory. Now that we have that class up here, I want to create a private val effects pipeline created instantly when the class is created. Of course, inside the onDestroy function, I want to get rid of this class, so like this. And then I'm going to write function, name it private suspend function run effects. It's going to get an input of type bitmap and then return another bitmap. So it will process our bitmap with AI integration. So we simply want to use effects pipeline, use a process function for the input. We'll simply pass the input to it. And for the enabled, so this data class of the FilterState is going to be video pipelines and use this data class. So the text recognition is going to be this state named filter text recognition. So now let's create these filter objects down here below this pipeline. So this is our pipeline, and here will be our filters list. So we will pass this filter text reconnection every time that we are going to process an image. So who's going to update this menu state? If you remember, we have added a reload filter configs. So inside this one, we're going to a FilterStorage config, and it's going to use the FilterStorage class and load the data using the application. And then we're going to update the value that we just created. So CFG and pass the text reconnection. So every time that filters are restarted, we update this state. And for each frame process, we are aware of that if we want to apply this filter to that. So we're going to use this run effect on each process. If you remember here, we wanted to process each frame using the filters options. So before we switch to the main, we actually want to create a processed image using run effect. And for the value, we'll pass the bitmap to it. After its suspense is finished and the value, the processed image is ready, it's time to convert it back to the video frame. So let's create the video frame using bitmap to video frame converter and convert it. The bitmap is going to be processed image up here. Rotation is going to be 0, and then we simply pass system.nanotime or current timestamp, whatever. Now that we have our video frame back from the process, it's time to use the local video source and use the capture observer and pass the new frame to the capture observer dynamically. So use the unframe captured and pass the video frame to it. pretty much simple. So what we have done so far is we launched a Kotlin scope inside the default dispatchers because it's a heavy work. Then using VideoFrame class, we converted each frame to a VideoV and extracted the bitmap out of it. Using the VideoFX pipeline, we decide which filters will be applied to the frame, and then we will convert back that processed image to the video frame using bitmap to video frame converter class that we just recently created and added to our project. And then we will switch to the main thread because it's a main thing to happen. And using local video source and capture observer, we dynamically pass the frame to the video source. Now we didn't manage our TextRecognitionEffect class. I'm going to copy and paste it here inside the image processor class. So all it does, it has a main function named apply. Actually, all of our filters work the same. So we will create a text recognition object using ML Kit library, and the option of it are going to be default options. We don't modify anything. And since it's a callback function, we want to suspend our coroutine scope. We use a suspend cancelable coroutines. And then when the process was successfully done, we then want to resume with the text that we just extracted from the resource and then draw to the block. So we will draw next to the object that was detected as a text. Otherwise, we will pass the video frame back to the usual. We don't want to drop the frame because we couldn't extract any kind of text. And this draw text block is generated function that will draw a block around the text and write extracted text on top of the block that you will see in a second if I run the application here. So inside our video effects pipeline, we have the object of it now. So before I run the application, I'll do two simple thing to surpass the video calls every time. Since these frames update are happening on our local stream, I'm going to move to our video stage section and change the width of my local surface view render to 72. And then inside my WebRTC factory class, I wanna use the back camera. So not every time I have to switch to the back camera. So let's run it inside my Samsung device, and using running device, I'm gonna show you the display of it. Now, if we open our application and press the call, you will notify that our local video track is not being generated. It's because we are doing this inside the Kotlin scope. So if we move it up, we should be able to see that the application is working. The local track is working right now. The switch camera function is also working. So normally it is not tracking anything. If we set the filters of the text recognition to the true, it should be a start extracting things. So you can see it's successfully generating text and setting it on top of each text block that is getting recognized. So that was our text recognition process, and the next ones are going to be easier because we set up everything. We just have to add the options to our project and start using ML Kit libraries. So till the next video, see you everyone.